देखिए नेक्स्ट एग्जांपल कैन बी टेकन वेयर वी कैन आस्क यू बॉन्ड एंगल्स कंपैरिजन ऑफ मॉलिक्यूल्स in which you can use one rule called as bend rule. The bend rule already explained to you. Bend rule can take 2-3 points here. First point can be taken what here? In trigonal bipyramidal geometry, lone pairs occupy equatorial positions and bond pairs at other positions, rest positions. Second point can be taken. इसका लॉजिक क्या होता है, बेस क्या है? इसका लॉजिक होता है, आई विल एक्सप्लेन बोथ द पॉइंट्स. नेक्स्ट पॉइंट क्या होता है? अगला पॉइंट देखिए, इसमें 2-3 पॉइंट्स हैं, पहले पॉइंट लिख लेंगे, देन आई विल एक्सप्लेन टू यू. इसमें अगला पॉइंट आता है इसके अंदर, अगेन इन ट्राइगोनल बाइपिरामिडल ज्योमेट्री, मोर इलेक्ट्रोनेगेटिव एटम्स और एलिमेंट एटम्स occupy or prefer to occupy axial bonds while less electronegative element at remaining positions. तो फर्स्ट प्रायोरिटी गिवन टू दिस पॉइंट, देन टू दिस पॉइंट. इसका रीजन भी होता है, we can take one modification taken as a whole कि lone pair occupy the positions in which or which have greater bond angles. लोन पेयर ऑक्यूपाई द पोजीशंस व्हिच आर हैविंग ग्रेटर बॉन्ड एंगल्स. इसका लॉजिक ये होता है कि लोन पेयर आर बल्कियर एज कंपेयर्ड टू बॉन्ड पेयर्स बिकॉज लोन पेयर हैव अट्रैक्शन बाय सिंगल न्यूक्लियस. इसका रीजन क्या होता है? सिंस द लोन पेयर ऑक्यूपाई मोर स्पेस देन बॉन्ड पेयर. नेक्स्ट पॉइंट विल टेक that the orbitals having more s character are bulky. Orbitals having more s character are bulky because if you take pure s orbital, if I take sp orbital will be like this. If I take sp2 orbital, some elongation. If I take sp3 orbital, more elongation. Because angle keep on decreasing by increasing p character or decreasing s character. It is pure s character. It has 50% s character. It has 33.3% s character. It has only 25% s character. It has 25% s character. So s character will be more. We have orbitals bulkier. They prefer to occupy those positions which are having greater bond angles and bond pair in the remaining positions. So it is the basis for this point. Now when we take, especially two geometries are there where we are having different bond angle. One geometry taken trigonal bipyramidal and second geometry taken is pentagonal bipyramidal. Let us take each geometry one by one and then this point explain bit more. Trigonal bipyramidal geometry, it have which hybridization is sp3d. It can be supposed to be made of two parts. It can be taken as sp2 plus pd orbitals. sp2 will give rise to trigonal planar geometry. pd will be axial bonds. When these two combine, they can give rise to the entire geometry trigonal bipyramidal. So this is combination taken. Now if it is taken these bonds, what is angle taken here? 120 degree. If you can recall sp2 hybridization. In sp2 hybridization, what is geometry trigonal planar and their bond angle also 120 degree. And pd orbitals become to the given geometry triangle, they become perpendicular. So we can say these orbitals are having no s character while they will have all s character. S character निकालते कैसे हैं? if you take ना combination दिया है 1s2p, तो we have total 3 orbitals, 1/3 s character and 2/3 p character in these orbitals. Here no s character, no s orbital there. To find this s character or p character, we have relation also. That relation taken is cos theta is taken s upon s minus 1, and cos theta can also be taken for p character calculation, p minus 1 by p. You can use any of the relation. Like if I take for axial positions, for axial position, what is angle taken? 90 degree. Axial position, if I take relation anyone, if I take suppose this relation, what is angle? Cos 90 degree is equal to how much? S upon s minus 1. What is cos 90 degree? 0. So 0 equal to s upon s minus 1, or I can add what is s character? 0. So for the axial positions there is no s character. While we take for equatorial positions, we can take, if it is second cos 120 degree is s upon s minus 1. Then on solving, what is s character coming? 0.33, or you can add here 33%. So it is also giving this evidence or support in this point. Now that the point taken here, when you take orbitals having more s character, they occupy the positions which are having greater bond angle. It is longer, higher bond angle, so lone pairs place this position, because lone pairs are having attraction by single nucleus. So lone pair occupy the positions which are having greater bond angle because they will occupy more space as compared to bond pair. So lone pairs are placed in these positions and then bonds in the remaining positions. Second point I told you in band show that more electronegative atoms occupy axial positions. More electronegative atoms occupy axial position. ऐसा क्यों होता है? Because they will cause more attraction for the bonding orbitals at the axial positions, and then they can cause more contraction of the longer axial bonds. By more contraction, they decrease the bond length and make stronger or stable bonds. For this reason, you can say here that the orbitals which are more electronegative are occupying the axial positions. For this reason only we can take PF5 is well known compound. PF5, PCl5 is known, but PH5 is unknown. This region could be explained in this concept. Hydrogen atoms are small in size. Second, they are not much electronegative, so they are unable to cause enough contraction of the axial bonds, of the longer axial bonds, and without much contraction they can't form stable compound. Without much contraction they cannot form stable bonds. So axial positions bond formation become difficult. So PH5 is unknown. For this reason PF5 is known. Are you clear this point? PF5 is known, PH5 is unknown because hydrogen atom पहला रीजन स्मॉल साइज होता है, सेकेंड रीजन क्या है? लेस इलेक्ट्रोनेगेटिव है हाइड्रोजन एटम्स, so they cannot cause enough contraction of the longer axial bonds. Without their much contraction they cannot occupy the axial positions in the given geometry. I hope it is clear. That is one point taken here, explanation of this band rule. Now further, if I take geometry pentagonal bipyramidal, one example taken with lone pair, one example taken XCF5 minus. In XCF5 minus we are having geometry pentagonal bipyramidal. Now if we take here, they can have two kind of bond angles. This angle taken 72 degree, this angle taken 90 degree, So as per the rule here, we told that lone pair occupy those positions by bent rule which are having greater bond angles. So we place lone pair at the axial positions which have greater bond angle. It is less bond angle, it is higher bond angle. Then the bonds are the remaining positions. Then the bonds are the remaining positions in Xc F have negative ion. G naught will carry negative 1 formal charge in this case. Xc F6 is exception to this bend rule. Xc F6 is exception to bend rule. Okay, so that is one point. One more point taken in bend rule, that a more electronegative atom occupy the orbitals with greater p character, and not only this, they also increase p character of the orbital they occupy. They also increase p character of the orbital they occupy. That is rule called as Bend's rule. Modification is there. Bend's rule modifications. It is one more point. Like we have taken axial positions are occupied by the fluorine atoms or more electronegative atoms when we had geometry trigonal bipyramidal, because they were causing their more contraction. Lone pairs are occupying those positions which are having greater bond angles because they need to occupy more space. Lone pair occupy more space than bond pair. So this all the points are based on that only observations. Now next we can take variation of bond angle, especially in the group number 15 and 16 hydrides. Now if we take the bond angle taken in ammonia molecule is 107 degree, and then the bond angle will change very little, but here they have rapid decrease in both the cases, and in the remaining case the bond angles are very close and will not decrease much. This observation could be explained by using one rule called as Drago's rule. Drago's rule, don't write dragon, it is Drago's rule. क्या होता है, लिख लीजिए स्टेटमेंट, लिखिए. It states that if central atom belong to third period and onwards, higher period or higher periods, and it is bonded to atoms with electronegativity 2.5 or less, then there is no hybridization around central atom. No hybridization around central atom. It is rule called as, or observation called as Drago's rule. As per Drago's rule, we can say in these molecules there is no hybridization. In these molecules there should be no hybridization as per this rule. This rule normally is not given in your NCERT. Your questions are not given on this rule, but it is for your clarification, knowledge, that as per Drago's rule, in these molecules there should be no hybridization. समझ में आया कि इसमें क्या सेंट्रल एटम कहाँ पे है? ये तो है सेंट्रल एटम बिलोंग टू सेकंड पीरियड, नाइट्रोजन, ऑक्सीजन. यहाँ पर क्या है? फास्फोरस, आर्सेनिक, एंटीमनी, फास्फोरस और सल्फर थर्ड पीरियड, फोर्थ पीरियड, फिफ्थ पीरियड एलिमेंट्स. They are in the same group. Group number 15 hydrides, group number 16 hydrides. In these hydrides and moving down the group, it says that there should be no hybridization around central atom. Because we have hydrogen atom, it is having electronegativity less than 2.5. So, as per this rule, there should be no hybridization. Even we can calculate hybridization by formula I gave you right now. Let us see the calculation of formula in pH3 molecule. If I take in pH3 molecule, what is bond angle taken here? 94 degrees. So if I take calculation cos 94 degree is equal to S upon S minus 1. On solving from here, S will come 0.02 or we get 2%. In the bonding orbitals, they will have S character only 2%. So the bonding orbital have S character only 2% as per this. So we can take 2% means negligible. So we can take here the bonding orbitals have more and more P character. So if it is S character, then they will have how much P character? 0.98 or we can write 98%. You can say almost pure P character. So if the question given to you, why the bond angle decreases on moving down the group in these hydrides or these hydrides? अब देखो ना दोनों में bond angle is decreasing or moving down the group. One reason was explained to you using Weisbach theory that on moving down the group there is decrease in the central atom electronegativity. So the bonding electron pair move away from central atom. So in them repulsion decreases. So bond angle decreases. Was one concept. One more concept can be explained using this concept. The bond angle decrease in both the cases. In both the series, the bond angle decrease due to increase in P character of bonding orbitals. Suppose we have pure P character, then what happens? Then when we have pure P character, the bond angles will be 90 degree among 3 P orbitals. This can be taken 3 P orbitals which are mutually perpendicular. So if we have pure P character, then they should have how much bond angle? 90 degree. What are bond angles here? Very close to 90 degree. This bond angle values are supporting Drago's rule. That says there should be no hybridization. So if you get your question, this answer suppose is given. This was the question given in once in examination of JEE Main or AATT. What happened, what the reason, and this was the correct answer given. Bond angles are decreasing on moving down the group. It is because of decrease in the S character or increase in the percentage P character of the bonding orbitals. It is because of increase in the percentage P character in the bonding orbitals, and it is correct option, explanation for this point. So I hope it's clear. This is called Drago's rule. Now let us take 1-2 question more. One question given to you: if you are given the CH2F2 molecule, in CH2F2 molecule, can you tell the bond angles of different bonds? If I write here CH2F2, 2 hydrogen, 2 fluorine. So we can have in this case 3 bond angles possible. One is taken alpha HCH bond, one angle beta HCF bond, one angle gamma FCF. ये तो common हो गया, HCF is common already. So we can have 3 kind of bond angles. In these 3 bond angles, can you tell the order of bond angles? Try this question yourself, then you see solution. Now let's come on solution part. This solution can be explained in 2 terms, 2 ways. One can be explained in terms of bonding electron pair are more close to fluorine and here comparatively close to carbon than hydrogen. So when you take the repulsion in the bond pair will be least here. So angle gamma will be lowest. Because bond pair have more distance, so they have least bond pair distance, bond pair repulsion, so angle is lowest. And then this alpha angle is maximum, and then definitely beta angle. It is one explanation in terms of distance in the bond pair because of atoms electronegativity. that fluorine atoms are more electronegative, so bond pair are lying more close to fluorine in CF bonds. So distance in the bond pair will be less and more distance, so repulsion become less. Less repulsion in the bond pair means angle become less. Here in CH bonds compared to hydrogen, carbon is more electronegative, so the bond pair is more close to carbon. They have less distance, more repulsion, so angle is maximum. This angle is intermediate. This is region explained in terms of atoms electronegativity. Other region can be explained using Bent's rule. What Bent's rule says that fluorine atoms will increase p character in the given orbitals. This bond have more p character. This bond have more s character. हमारा point क्या था? More electronegative atom occupy that orbital which have more p character, and not only this, they also increase p character of the orbitals they occupy. So this is more p character. P character more means there will be thinner orbitals. More s character means bit thicker orbitals. So they will cause more repulsion. They will cause less repulsion. Less repulsion means angle is less. They will cause more repulsion, so angle will be more, and this repulsion will be intermediate of two values. So this answer can be explained in this term also, bond angles, repulsions. So this kind of question can be given to you. You have to be just careful for solving such questions. And it is this topic taken hybridization, Bent's rule, modifications of Bent's rule, Drago's rule, bond angle comparison in terms of Bent's rule or Drago's rule. So it is this topic taken. Now next we take in theories of bonding will be coming molecular orbital theory. But before we take that theory, we will take one topic more, dipole moment. It is linked to the molecule shapes, bond angles. So easily you can explain the topic dipole moment. So we will first take topic dipole moment here, and then we will take next topic hydrogen bonding, then we will go for molecular orbital theory. Okay, so let us next topic we are starting is now dipole moment.